Q11 of May 2022, Paper 1. And in Part A, we're asked to show that the three planes do not intersect. Okay, so you can use simultaneous, you can solve this, you can show that they do not intersect by solving the equations of the planes simultaneously. So first I'm going to use the first and second equation, so let me decrease my pen's thickness. 2x minus y plus z equal to 4. So I'm going to get rid of the x, negative 2x, multiply that by negative 2. So negative 2x plus 4y minus 6z minus 6z equal to negative 10. This will be 3y minus 5z equal to negative 6. Right. And then I'm going to use the first and third equation. Multiply the first one with, what should we multiply it with? This the only. Well, let's go with the second and third. Seems more logical. So we can multiply the second one with 9. It's going to be 9x minus 18y plus 27z equal to 45. Negative 9x plus 3y minus 2z equal to 32. The 9's cancel out, and this will be negative 15y plus 25z equal to 45 plus 32. So 45 plus 32 is 77, right? I'm assuming you can factor out what? Can we factor out anything from here? I guess we can't. Okay, so now what? We can solve the first equation and the second equation again simultaneously. So 3y, we multiply this by 5, so 15y minus 25z equal to negative 30, then negative 15y plus 25z equal to 77. Interesting. So 0 is not equal, definitely not equal to 47. So through this you can say that the three planes do not intersect. Alright, and BI, we're told to verify that the point P1 negative 2, 0 lies on both P1 and P2. So you can go ahead and substitute in the coordinates of P1 and P into both these equations and see if it is true. So I'm going to skip that. Okay, find a vector equation of L, the line of intersection of P1 and P2. Vector equation. So you can use cross product of P1 and P2. It's going to be 2, negative 1, 1, 1, negative 2, 3. So that's going to be I negative 3 plus 2 minus j 6 minus 1 plus k, negative 4 plus 1, so negative I minus 5j minus 3k. Let me quickly check if this is right. I think it is, but just for the sake of time. One, 5, 3. Yeah. So the direction vector of line L will be 1, 5 dl 1, 5, 3. So you can write L equal to the point P 1, negative 2, 0 plus lambda 1, 5, 3. Alright, so now we're asked to find the distance between L and P3. So P3 is, of course, a plane, and L is a line. P3, and then here's the line L. This is line L. So in order to find the distance, of course, you have to imagine a perpendicular line going from P3 to the L, so they're perpendicular. And then this is, I'll consider this point A and this point B. And what else? So if you want to write the vector equation of this AB, well, I have a point on line L, point P, so I can use that, 1, negative 2, 0, then plus lambda. I can use the normal vector of the plane P3, right, because this is obviously a normal. So negative 9, 3, negative 2. Negative 9, 3, negative 2. And I guess it's better if we use another constant instead of lambda. So I'm going to use t. I'm going to use tau. I don't like the way t looks, so tau. Okay, so x will be 1 minus 9 tau, and y will be negative 2 plus 3 tau, and z will be negative 2 tau. So if you substitute in, so our goal is to find the point on P3, which this line AB goes through, right? So you can substitute in these x, y, and z in the equation P3 to find the constant tau. So negative 9 times 1 minus 9 tau plus 3 negative 2 plus 3 tau, and then minus 2 negative times negative 2 tau, which is plus 4 tau, equal to 32. So this is going to be negative 9 plus 81 tau minus 6 plus 9 tau plus 4 tau equal to 32. So the 9's, okay, no. So this will be negative 15 plus 94 tau equal to 32. And then 32 plus 15 is, I think, 47, right? Yeah. So tau will be 1 over 2. Okay, so tau is 1 over 2. Now you can solve for the x, so x will be 1 minus 9 over 2, negative 2 plus 3 over 2, this will be negative 1, so 2 minus 9 is negative 7 over 2, then negative 4 plus 3 is negative 1 over 2, negative 1. Okay. So the point on P3 where the line AB intersects is negative 7 over 3, negative 1 over 2, negative 1. Okay. So I guess now you can find the distance of this point. I'll call this A, right, from P. So AP, the magnitude of AP will be 1 minus 1 plus 7 over 2, then negative 2 plus 1 over 2, then 0 plus 1, which is radical 9 over 2 squared plus, it's going to be 4 plus 1, I'm sorry, negative 2 plus 1 over 2 is negative 3 over 2, so 3 over 2 squared and plus 1. So this will equal to 81 plus 9 plus, I'm going to multiply that by 4. So you can bring out the 1 over 4 and this will be 1 over 2. 81 plus 9 plus 4 is, it's going to be 94. So radical 94 over 2 is your answer for the distance between L and P3.